Alright, here is a short review video, and I'm creating it based on the responses that I got from my daily question, which said, which topics in Chapter 2 do you feel you need more help with? And I feel the most common responses were area of parallelograms, area of trapezoids, triangle inequality, maximum and minimums, and Pythagorean theorem. Now, if this is all I'm going to cover in this video, but if there are additional questions, please reach out and ask them, especially as you start working on the Chapter 2 review. Okay? We're going to start here with the area of a parallelogram. I can see here, based on, and you'll have this formula because it's going to be part of a note sheet that you're going to make, but the area of a parallelogram, and I'm going to try to write that out, area of parallelogram is base times height. And if you remember from my video or from in class, that is that case because you can take this triangle down here, shift it up, and you can create a rectangle without actually changing the area. So it has the same formula. Okay, we then look at, okay, what do I have? Well, the line that connects the parallel line to the other parallel line, that's my height. So my height in this case is 3. And then one of the parallel lines, which they give us one of them here, is going to be my base. And so I have a base of 6.6. Then it's just a multiplication problem. 3 times 6.6, which, using a calculator, because I don't do decimals well, I get 3 times 6.6 giving me 19.8 as my area. So just remember, base times height is the same as a rectangle or a square. Trapezoid area is a little different, but it was based off the lesson we learned. It's based off of the parallelogram, but it's different. And so we see it as area of trapezoid is base 1 plus base 2 times the height, and all of that gets divided by 2. Okay? Well, here I have base 1 being 1.6. I have base 2 being 4. And so this is 1.6 plus 4 multiplied by the height, which is, again, the line that's going to connect one parallel line to the other. And so in my case, it's going to be 2. And now this whole thing is going to be divided by 2. If I extend it here, 1 second, I get 1.6 plus 4. That's going to give me 5.6 times 2 all over 2. That's going to give me, I got to use my calculator again, 11.2 over 2. And when I divide it, I get 5.6. Look at that. And that is the area of my trapezoid using the trapezoid formula, which again is this right here. Okay? The next one is going to be the triangle inequality. And so we want to find what's the maximum length this side could be and what's the minimum length this side can be. Well, we knew in class that when you add up to two side lengths, they always need to be bigger than the third length. And so right now, to find my maximum, I'm going to add my two side lengths, 17 plus 16, and that's going to give me, checking on my calculator so I don't screw it up, 33. Okay? And so 33 is going to be my maximum, meaning 33 technically doesn't work, so 33 is the breaking point, and anything bigger than 33 is not going to work, and so we say that that's our maximum because, again, a number like 32.999 repeating, that number would work. But as soon as we hit 33, it stops working because these two added up equal 33, and so we say it's the maximum. Okay? For the minimum, we do subtraction instead of addition. So 17 minus 16, that gives me 1 as my minimum. And again, numbers like 1.0001, that number works. The first time that this doesn't work as a side length would be 1, because if I put 1 in here, 1 plus 16 equals 17, that doesn't work, but anything bigger than 1 does work, so we say that the minimum is 1. Okay? And that is how you do minimum maximum, just adding side lengths and subtracting side lengths, and it's it is that simple. Just the idea of it has to be bigger than that gets a little confusing, but we do say those are the max and min. Lastly, we have Pythagorean theorem problem, okay? We have a leg here, 2.7, and we know 6.5 is going to be my hypotenuse because it's across from my 90-degree angle, okay? Hypotenuse is the longest side, and the longest side is always across from your 90-degree. My Pythagorean theorem is a squared plus b squared equals c squared. Now I plug in what I know. Well, a or b, I can choose which leg I want to use, but I'm going to choose 2.7 to be my b. So I have a squared, because I'm missing this leg over here, plus b squared. I'm going to replace with 2.7, because that's one of my legs. So 2.7 squared equals my hypotenuse squared, which is 6.5 squared. Now I got to use my calculator here, because again, I'm bad with multiplying decimals, but a squared stays a squared, plus 2.7 squared. So 2.7 times 2.7 is 7.29. And then I have 6.5 squared, which is 6.5 times 6.5, which gives me 42.25. Now, I need to get a all by itself. So I have a squared. Let's get that by itself first. So subtract over the 7.29 on both sides. And I'm going to put that in my calculator, minus 7.29 from that. And I get that a squared equals 34.96. Now again, I want a by itself. I have a squared right now. I don't want a squared. I just want a. So I have to square root both sides to get rid of that. Square rooting a squared gives me a, which I want. And then I have the square root of 34.96, which gives me 5.91 after I round it. And that is an example of the Pythagorean theorem solving for this missing side right here. The only other variation that you'll see to the Pythagorean theorem, here we were given a hypotenuse and a leg. In some cases, you're going to be given two legs and you're going to be asked to solve for the hypotenuse. So always start with this original equation and plug in what you're given and solve for the missing variable. Okay? Again, these are the four examples that I saw the most people say they wanted help on. If you have other problems that you want additional help on, just let me know by shooting me an email.